August 1944. The American Third Army, under the command of General George S. Patton, Jr., had broken out of the hedgerow hell of Normandy and was moving with a terrifying, unforeseen speed. This was not the grinding, trench-style warfare of the past. This was a blitzkrieg against the blitzkrieg. Patton's tanks and trucks were averaging 50 miles a day, sometimes pushing 100 miles, a pace that shocked the retreating German forces. But this very speed created a strategic crisis that threatened to collapse the entire Allied advance. The German army had employed a scorched earth policy, methodically destroying bridges, rail lines, and, most critically, paving. The massive weight of American logistics, thousands of GMC trucks and tons of material, quickly chewed up the remaining French infrastructure. When the roads broke down, the advance stopped. When the advance stopped, the Germans could regroup. The engineers of the U.S. Army Corps of Engineers faced an impossible logistical paradox. They had to support an army that was moving faster than any army in history, but their tools were rooted in the past. To build a solid road or an operational airfield required weeks of specialized work, bringing up heavy rollers, grading the soil, laying down concrete or asphalt, and waiting for it to cure. The German approach to construction, rooted in the philosophy of durability and permanence, only exacerbated the problem. German engineering dictated that if you build for 100 years, a slow, meticulous process that required the importation of tons of specialized cement and aggregate. This methodology was completely incompatible with Patton's mantra: hold them by the nose and kick them in the pants. The American army did not need a road that would last a century. They needed a road that would last a week, and they needed it now. The most critical bottleneck was the air war. The Luftwaffe, though crippled, still possessed the capability to strike. To maintain air superiority and protect the advancing ground troops, the 9th Air Force needed forward operating bases, airfields located just behind the front line. Without quickly built, stable runways, the P-51 Mustangs and P-47 Thunderbolts could not cover the necessary distances, leaving the armored columns vulnerable. Building a single runway using traditional, capital-intensive methods could take 3 to 4 weeks, a delay that meant the air cover would always be 300 miles behind the action. The strategic value of American air power was being neutralized by French mud and German demolition charges. The enemy of the advance was simple, humble mud. The vast tank parks and logistical staging areas turned into deep, impassable mires after the slightest rain, immobilizing thousands of tons of critical supplies. The heavy trucks of the Red Ball Express, the backbone of the supply effort, were sinking into the earth faster than they could deliver fuel and ammunition. Into this crisis of speed and mud came a solution that defied traditional engineering wisdom: the pierced steel planking, PSP, soon nicknamed Marston matting. It was an invention born not of aerospace elegance or naval shipbuilding, but of Depression-era pragmatism and a singular focus on expediency. The material was simple, crude, and initially scorned by old guard engineers. It consisted of 12-foot long strips of thin, perforated steel, weighing a mere 66 pounds each. The design was almost insultingly basic. German engineers, witnessing the first PSP airstrips, were said to have laughed at the crude steel carpet and the way the metal strips rattled under the wheels of the planes. To them, it represented the American fixation on shoddy, temporary solutions over true, permanent construction. They saw a weakness in the holes and a lack of finesse in the simple hook and slot attachment system. But what they saw as weakness was, in reality, the core of an unstoppable strategic advantage. This ugly, crude steel matting was the key that would unlock the lightning speed of Patton's advance, allowing the American army to move 300 miles faster than any force the Wehrmacht could bring against them. The struggle was no longer about fighting the enemy. It was about defeating the enemy's most potent ally: friction and time. The brilliant simplicity of the pierced steel planking, PSP, was the direct answer to the German philosophy of "build it to last." The invention, primarily developed by engineers like Gerald G. Knoll, solved the fundamental problem of weight versus utility. Each plank measured 12 feet long and 15 inches wide and weighed approximately 66 pounds. This seemingly arbitrary size was actually a masterpiece of ergonomic and logistical design. It was the heaviest object that two ordinary soldiers could easily carry and quickly position, even under duress. The genius, however, lay in the perforations, the series of precise punch-out holes that gave the matting its distinctive, ugly, holy appearance. The German engineers saw these holes as a structural weakness and an aerodynamic flaw. But Knoll and his team had performed the physics. The holes served three critical, non-obvious functions. First, they dramatically reduced the weight of the steel strip. This was crucial for logistical speed, allowing 5 times as many planks to be carried by a single GMC supply truck compared to an equivalent volume of solid paving material. The speed of supply was paramount to Patton's rapid advance. Second, the holes provided anchorage. When the matting was laid over soft ground, the mud and soil would squeeze up through the perforations. This material then solidified, locking the individual planks to the earth, creating a surprisingly stable, semi-floating surface that prevented the whole strip from sliding or shifting under the weight of aircraft or tanks. Third, and most critically for the battle against mud, the holes provided drainage. A solid, non-porous surface, like a concrete slab, would trap water underneath and turn the subsoil into a liquid slurry, causing the entire slab to sink and fracture. The PSP allowed water to drain through the matting, preventing the buildup of hydraulic pressure and resisting the suction that threatened to engulf heavy vehicles. The holy design, dismissed as primitive, was actually engineered to float the runway on top of the mud, rather than sink into it. The final element of genius was the attachment system, a simple, built-in hook and slot mechanism. No complicated bolts, no welding, and no specialized tools were required. A team of 8 minimally trained soldiers, not skilled engineers, could arrive at a captured field, unroll the PSP, and snap the planks together like giant pieces of metal carpet. This simple, brute force modularity allowed the Corps of Engineers to lay 5,000 feet of usable runway in under 48 hours. For the German Army, building an equivalent runway using their capital-intensive, durable methods required weeks of work with steamrollers, asphalt, and scarce materials. The American system, rooted in the philosophy of temporary, scalable, and instantly deployable materials, had turned infrastructure construction from a monumental task of architecture into a simple task of assembly. The speed of that assembly was about to become the defining feature of the Western Front. The strategic impact of the humble pierced steel planking was most immediately felt in the air war. The PSP transformed the way the Allied air forces supported the ground offensive, neutralizing the Luftwaffe's capability to strike at the supply lines. The German strategy against Allied air superiority relied heavily on the predictability of airfield location. The Luftwaffe knew that building a capital-intensive runway took weeks, giving them time to prepare defenses or launch counterstrikes. But the American system was based on disruptive speed. The PSP allowed the 9th Air Force to establish instant airfields, forward operating bases that could be constructed literally within earshot of the front line. Engineers arriving at a captured Belgian or French farm field, often minutes after the last German troops had retreated, would begin rolling out the steel matting. The 48-hour construction window for a fully functional runway meant that the Luftwaffe, after losing a forward base, had no time to establish defenses or even properly map the new Allied position before American fighters were launching missions from the field. German pilots, accustomed to fighting air battles deep over enemy territory, were suddenly reporting that Allied air cover was appearing from locations that reconnaissance photos showed were mere potato fields yesterday. This was not just a tactical advantage, it was a logistical miracle. The PSP strips were transported exclusively by the same GMC trucks that were the backbone of the Red Ball Express. A single GMC could carry enough PSP to lay a significant portion of a runway section. This meant that the essential material for air superiority was integrated directly into the general supply chain, bypassing the need for separate heavy engineering convoys. The speed of supply was directly proportional to the speed of construction. The simple fact that 8 minimally trained men could lay 5,000 feet of runway in 2 days was the numerical proof of American industrial philosophy. The material was quickly stamped out by 10 separate American fabrication plants, achieving a production volume that dwarfed anything the Germans could dedicate to road construction. The PSP was an inexpensive, disposable, standardized commodity, not a complex engineering marvel. This logistical leap paralyzed the German air defense. The P-47 Thunderbolts and P-51 Mustangs could now operate from bases that advanced 100 to 200 miles forward of their original English bases. This drastically cut down on transit time, increasing the time they could spend on target and the number of sorties they could fly per day. The PSP had effectively eliminated the geographical bottleneck created by German demolition. The American air superiority was no longer tethered to fixed, vulnerable infrastructure. It was now a mobile, expanding, unstoppable force. The most direct and brutal application of the Marston matting was in solving General Patton's logistics problem. By September 1944, Patton's Third Army was a victim of its own success. The speed of the advance, the sheer pace of the tanks, half-tracks, and jeeps meant that the Army was literally outrunning its supplies. The supply effort, spearheaded by the heroic, non-stop convoys of the Red Ball Express, was constantly plagued by bottlenecks where roads deteriorated under the immense weight or were deliberately destroyed by retreating German sappers. Traditional engineering solutions were too slow. If the German army blew up a key bridge or cratered a vital intersection, the American advance would halt, sometimes for days, while engineers struggled with timber, steel girders, and heavy earth-moving equipment. Every hour of delay allowed the Wehrmacht precious time to regroup and consolidate their defenses. The PSP became the instant infrastructure that maintained the momentum. It was used not just for runways, but for creating instant bypasses, tank staging areas, and quick reinforcement of soft shoulders on existing roads. When a critical stretch of road dissolved into impassable mud under the weight of thousands of GMC trucks, the engineers simply rolled out the PSP. It didn't make the road perfect. The steel strips rattled and groaned, throwing up dust and noise. But it made the road usable. The simple hook and slot system allowed combat engineers, often working under fire, to lay down a path across a muddy field or over a collapsed section of road in a fraction of the time required for traditional construction. The strips were light enough to be handled manually, eliminating the reliance on specialized cranes or bulldozers, which were often stuck or far behind the front. German commanders, trained to think in terms of massive, static infrastructure, constantly wasted resources on methods of demolition that were ineffective against PSP. They blew up a concrete bridge, expecting the advance to stop for a week. Instead, American engineers would throw up a temporary Bailey Bridge nearby and, critically, use the Marston matting to rapidly reinforce the soft, muddy approaches to the temporary bridge, ensuring heavy vehicles could reach it without sinking. The PSP wasn't about replacing the highway. It was about replacing the friction. This system guaranteed that the pace of the advance, the one thing the German army could not counter, was maintained. The ability to keep the Red Ball Express moving, delivering thousands of tons of fuel and ammunition daily, hinged on eliminating those 5-hour, 12-hour, or 24-hour delays caused by mud and demolition. The simple, ugly, perforated steel strips were the unseen, uncelebrated technology that allowed Patton's corps to maintain the terrifying 100 miles per day momentum that broke the back of the German defenses in France. The core conflict between German and American military engineering was never more apparent than in the debate over the pierced steel planking. German propaganda, and more tellingly, internal engineering assessments, derided the PSP as a temporary, crude, and inferior solution. They correctly pointed out that the material was noisy, threw up excessive dust, and certainly would not last the lifespan of their own expertly compacted asphalt or concrete roads. To the German mind, rooted in the values of permanence, architectural quality, and efficiency of material use, the American PSP was the epitome of waste, a testament to American reliance on sheer, unintelligent abundance. However, this criticism was the strategic blind spot that ultimately cost them the war of movement. The German engineers saw a road as an enduring asset that must be maintained and recovered. American engineers, operating with the pragmatism forged during the Great Depression, viewed the PSP as a disposable, expendable commodity, a mere consumable like a bullet or a fuel barrel designed solely to facilitate the next day's advance. This philosophical difference fundamentally altered the logistics of the front. The German army, when forced to retreat, often spent precious resources and time attempting to demolish or recover their capital-intensive paving materials. If they couldn't recover it, they considered it a total loss of scarce resources. The American system, by contrast, embraced the concept of throwaway infrastructure. Once the front line had advanced 50 or 100 miles beyond a PSP-covered airstrip or staging area, the steel matting was often simply abandoned. It had served its purpose. The engineers were already rolling out new PSP at the next staging area. The cost of recovering and transporting the used steel backwards was deemed higher than the cost of simply manufacturing a new, easily stamped strip. This expendable simplicity provided a decisive numerical advantage that the German High Command simply could not comprehend. For every mile of road the Germans built, they had to allocate logistical support for transporting the material forward and transporting the heavy recovery equipment backward. For every mile of road the Americans built with PSP, they allocated support only for the forward movement of the new material. This huge logistical relief freed up thousands of GMC trucks and hundreds of engineers, allowing the Red Ball Express to dedicate its maximum capacity, thousands of tons of fuel and ammunition daily, to the front lines rather than to infrastructure maintenance. Furthermore, the PSP dramatically decentralized the process of infrastructure maintenance. Instead of relying on vast, centralized concrete mixing plants or asphalt factories, prime targets for Allied bombers, the PSP was stamped out by dozens of small, scattered American steel fabrication plants, which often used less critical steel grades. This meant that the production of the strategic material was bomb-proof and scalable. The German High Command could destroy the major bridges and the main highways, but they could not destroy the concept of rapidly deployable, modular infrastructure. The American capacity to mass-produce this crude material became, in the eyes of the German logistics officers, the ultimate symbol of unbearable industrial abundance. The speed with which these temporary roads and airfields appeared was a continuous, demoralizing reminder that the German army was not fighting just soldiers, but the entire industrial might of the United States. The PSP proved that the most valuable asset in modern warfare is not permanence, but the speed of adaptation and replacement. The strategic zenith of the pierced steel planking system occurred during the push toward the Rhine and the Battle of the Bulge. Here, the PSP transitioned from being merely a solution to mud and demolition into a component of a truly mobile fortress that enabled the continuous operation of American forces, regardless of enemy action or weather. The success of the American advance was intrinsically linked to the ability of forward air control units, TACs, to maintain communication and tactical support. The PSP allowed tactical airfields to advance literally with the Army, often leapfrogging one another. As the front moved, one PSP strip would be rolled out at a captured farm, while the PSP from the field 50 miles behind was being picked up and transported forward for the next jump. This constant, seamless leapfrogging gave American air power a decisive, continuous presence over the battlefield. The tactical consequence was immediate. The German ground troops rarely saw a moment when they were not under the threat of Allied air attack. The final strategic blow was the psychological effect on the German command. When the Wehrmacht launched the desperate Ardennes offensive, the Battle of the Bulge, in late 1944, their plan hinged on two critical assumptions: surprise and the inability of the Allies to quickly bring their overwhelming air power to bear due to winter weather and the lack of nearby airfields. The PSP system shattered both assumptions. When the weather cleared, the American engineers were able to utilize the PSP not only to quickly clear and repair bomber runways damaged by snow and ice, but also to rapidly deploy small, forward fighter strips that had been previously built in secret. The speed with which the 9th Air Force and the RAF could generate massive numbers of sorties from these quickly deployable PSP strips was the primary factor in stopping the armored thrust of the German tanks. The material, designed to float on soft soil, now proved resistant to sinking in thawing winter mud. The cumulative output of the PSP system was mathematically crushing. By the end of the war, American factories had stamped out an astonishing 70 million square feet of PSP, enough to cover 1,500 miles of runways. This incredible scale meant that the destruction of any single PSP strip was strategically meaningless. The Americans simply rolled out another mile. 10 separate American factories were constantly stamping this material, while the German construction effort was manually trying to maintain a few hundred miles of vital roads. The sheer, overwhelming industrial output of simple, perforated steel rendered the German demolition efforts futile and the German strategic planning obsolete. The PSP proved that to defeat American logistics, the enemy would have to destroy the entire American industrial economy, not just its forward bases. The war eventually ended, and the simple steel strips of the Marston matting remained scattered across thousands of European and Pacific battlefields, a rusty, rattling testament to the industrial philosophy that won the war. The legacy of the PSP was not merely technical, it was a profound strategic lesson about the value of expedience over elegance. This final chapter is the ultimate testament to the philosophical divide that separated the victor from the vanquished. The material itself was so effective that it continued to serve as the global standard for rapid airfield construction through the Korean War and into Vietnam, becoming the universal symbol of the American capacity to create infrastructure out of nothing. The story of the PSP, in the years following the conflict, became a cornerstone lesson in military logistics academies worldwide, that the simplest, most modular solution often holds the highest strategic power. Contrast the final fate of the opposing engineering philosophies. The German roads and autobahns, built with the intention of lasting centuries, mostly remained after the war. But those durable, perfect roads were unable to prevent the collapse of the German army because the supply routes leading to them were constantly severed by mud and lack of maintenance. The magnificent German engineering was defeated by the simplest elements of nature, water and soil, because the design was too rigid and too resource-intensive to cope with disorder. The American PSP, conversely, was designed for disorder. It was noisy, rough on tires, and aesthetically ugly, but it performed the one task that mattered. It supported the continuous movement of heavy vehicles and aircraft over unstable ground. It was the perfect solution for a blitzkrieg army operating under hostile conditions. The philosophical lesson learned from the perforated steel was that in an industrialized, high-speed conflict, the speed of repair and deployment holds the highest strategic value. The material that is cheap, simple, and can be laid in hours is worth infinitely more than the material that is durable, complex, and requires weeks to cure. The engineers who prioritized ease of stamping, simple handling, and rapid hook and slot assembly over traditional structural integrity were the true strategic masters of the conflict. The story of the Marston matting is the ultimate narrative of how the pragmatic, mass production mindset of the American economy defeated the refined, resource-constrained craftsmanship of the German system. It wasn't a tank or a bomber that sealed the German fate. It was the ability of American engineers to create a usable runway, a bypass, or a staging area literally overnight. The PSP allowed the Allied logistics machine to maintain a continuous, unstoppable flow of fuel, ammunition, and replacement parts that the German defense, hampered by its own slow, heavy construction philosophy, could never match. The final verdict is clear. The road that wins the war is not the one built to last a century, but the one built fast enough to be finished before the enemy can even draw it on a map.